Hey guys, today we're taking a look at logarithms to bases other than 10. Up until this point, we've really just looked at common logs, which are log base 10. In other words, if I saw a log of 100, I know what I'm looking for is the power that I raise 10 to in order to get 100. And that log of 100 would be equal to 2. Well, we can take logs with different bases. Now, before we get into our notes today, let's just kind of step back and remember that logarithms are simply the exponents you raise a base to in order to get the power. Now, n is the logarithm of m to the base b. It's written such as this. N, the exponent, is equal to log base b of m. M is the power, b is the base. Therefore, b to the nth power is equal to m. Now, remember, these are inverses of each other, this exponential form and this logarithmic form. So their graphs will be reflections over that line y equals x. So let's take a look at the just general form of the graph of log base b of x. When we take a look at its domain, you can see here it is graphed on the right. Its domain looks like it's going to be all reals greater than 0 because it's not going to ever be equal to 0. Our range here is going to be all reals. You can see that it continues off indefinitely down and it keeps growing up and up. Our asymptote, remember, is the line that this graph approaches but never touches. Well, that's going to be our y-axis here. It's the vertical line x equals 0, or you could just write it as the y-axis. Now remember, this is all a reflection of our exponential curve over the line y equals x. All right, let's jump into a few examples for today. Example 1 says, we're given the exponential form and we want to write it in logarithmic form. Now what you'll notice is that our bases are no longer equal to 10. So you see here our base in exponential form is 3. 3 to the 4th power is equal to 81. Now the way we write that in logarithmic form is log base 3. That's our subscript. Our subscript is always equal to our base. 81 is equal to our exponent. All right, let's try this next one. 3 to the 3rd is equal to 27. So again, we're going to write log base 3 of 27 is equal to 3. The subscript represents the base. What it's equal to represents the exponent. The 27 here is my power, and that's what comes right after my log of the base. All right, let's go back the other way. Now we have log base 3 of 9 is equal to 2. If I wanted to write this in exponential form, 3 is my base, 2 is my power, or my exponent, and 9 is my power. All right, going back the other way for this next one, we have log base 3 of 4 is equal to 81, so 3 to the 4th is equal to 81. There's a few more examples here. If we scroll down here and on your notes, you can see number 5, 3 to the 1/2 is equal to the square root of 3, writing that in logarithmic form. Again, we have log base 3 of my power, which is root 3, is equal to my exponent of 1/2. 3 to the negative 3 is equal to 1 over 27. So again, we have log base 3 of 1 over 27, that is my power, is equal to this exponent of negative 3. All right, in example 7 says to write this equation, p equals 12 times 0.359 to the x power in logarithmic form. So this is in exponential form. However, we don't have our base isolated. Remember, the base is always the number that we're raising to that power. So I first need to move my 12 over to the other side. And the way I'm going to do that is the inverse operation of multiplication, because 12 is attached to my base by multiplication. So I need to divide both sides by 12. So I get p divided by 12 is equal to 0.359 to the x. Now, this is in my pure exponential form. I can write this in logarithmic form. My base is 0.359, so I'll write log. My subscript is my base, 0.359. My power here is p over 12 should be equal to x, which is my exponent. All right, looks a little confusing, but try to keep everything straight. The subscript is always the base. The power is what goes next to that log with that base, and it's set equal to the exponent. All right, a few more examples for today. It says evaluate the following. Well, log base 2 of 16 is equal to x. In other words, x is the power I raise 2 to in order to get 16. Well, we know 2 to the 4th power is equal to 16. Therefore, this value of x must be equal to 4. All right, next up says log base 6 of this power of the square root of 6 should be equal to x. So 6 to some power is equal to the square root of 6. Well, we know that this square root of 6 is really 6 to the 1/2. And so we can say 6 to the x must be, our x value must be equal to 1/2. All right, next up we have log base 3 of 1 over 81 is equal to this logarithm here. So in other words, 3 to what power is going to be equal to 1 over 81? Well, remember, 81 can be written as a power of 3, and 1 over 81 is just written to that same power, but now it's negative. 81 is a power of 3 to the 4th. So if I write it as 3 to the negative 4th, then I know 3 to the x must be equal to 3 to the negative 4th, and therefore x must be equal to negative 4. All right, scrolling down now, we can use logarithms to solve equations. So you notice here we want to solve for our variable. Looks like we're looking for the power here. So it says log base 81 of a, our power, is equal to 5/4. Now if I take that and rewrite that in exponential form, that means 81 is my base, 5/4 is my exponent, and a, the value I'm looking for, is my power. So let's evaluate 81 to the 5/4. Now you'll remember that this means we're taking the 4th root of 81 and then raising that to the 5th power. 4th root of 81, as we just found out, was 3. 3 to the 5th power is 243. Check my notes on that. Yep, that's good. 243. All right, next one up is b. Here we see that log base z of my power is equal to 3/4 the exponent. So if I write this in exponential form now, z is the base I'm looking for here, to the 3/4 is equal to 8. All right, now in order to solve for z, remember how to undo this power. I'm simply going to raise both sides to the reciprocal power. So I'm going to take 8 and raise it to the 4/3 power, which again means I'm going to take the cube root of 8 and then whatever that result is, take that to the 4th power. So the cube root of 8 is 2. 2 to the 4th is equal to 16. So the value for z is 16. All right, next up we see log base 4 of my power here is equal to 5. That means in exponential form, if I rewrite this as 4 to the 5th power is equal to b. Well, 4 to the 5th, if I do that out correctly, b should come out to equal 1024.